right, it is my pleasure, right, to introduce here our keynote speaker, Talha Tariq. And Talha, of course, is the Vice President, Chief Security Officer at HashiCorp. And you guys being in the cloud space, you've probably heard of and are familiar with and used various tools from HashiCorp, probably most well known for their Vault solution here in terms of secrets management, as well as Terraform in terms of your cloud infrastructure as code. And when I reached out to Talha a while back and asked, hey, would you be interested in doing the keynote? I was super excited that he responded pretty much right away and said, yeah, Frank, I'd be happy to do this, right? And it's not only because of his experience at HashiCorp, but it's his prior experience as well in terms of his prior CISO roles, his consulting roles at PwC, previous engineering and leadership roles at Microsoft and NCR. And with that, I'm super excited to have Talha here giving his keynote here on trends in modern cloud security operating models. So Talha, welcome. Thanks so much. Turn it over to you.
Thank you, Frank. Super excited to be here. Hello, welcome. Good morning, good afternoon, good evening from wherever you are. Let me start sharing my screen. Perfect. All right, so super excited to be here. I wanted to take an opportunity today and talk a bit about a few different things. One, given our positioning in the market, some of the trends we see with our customers on moving their infrastructure to cloud. As they are moving their infrastructure to cloud, what are the kind of trends and best practices we are seeing with our customers? And some of those are pretty uniform across, regardless of whichever vertical or sector you are in. I'm also going to talk a bit about what HashiCorp security journey is as we are thinking about building a modern security program from scratch. And then finally, we'll leave a little bit exercise for the readers to go experiment with a few things that I'm going to talk about. So with that, just a quick intro. As Frank mentioned, I run security at HashiCorp. I've been here for about 3 years. Mostly focused on building the programs, but also influencing security features of our products. So before that, I was at Microsoft, PwC, and a few startups, one of them being Anki. My LinkedIn and my Twitter is here. I'm mostly more interactive on LinkedIn. Cool. So 4 different topics today, cloud security trends. I'm going to talk about security program at Hashi, and then mostly cover high level different aspects of the security program on prevention, detection, response, recover. And I'll try to touch a bit about modern data privacy programs as well. So just a quick word about ourselves, who we are, what we do. We provide infrastructure automation and security tools. Some of you, actually most of you may be familiar with at least one of the products listed on the right-hand side. We offer open source, commercial, and cloud versions of these tools. Cool. Let me transition into what does security at HashiCorp look like. And I want to start with our program because people build programs and people are the nexus of how security programs function. As we take a step back and think about security and what it means at HashiCorp, we have 4 broad objectives. Number 1 being we want to protect our company, secure our products, give assurance to our customers, and educate our stakeholders on their responsibilities. These are our 4 main tenets. This is what we focus on day to day, and most of our security program derives to meet these core objectives. The way we are organized is 6 different pillars, and some of these might look familiar. You may find relevance with your teams and your programs. But no one team and no one program is one size fits all. But this is what has been working really well for us. Left to right, just broadly covering what we do. Our product security team focuses on core security of our products. We work very closely with our product lines to design, build, ship secure software, and manage the lifecycle. Our detection response and cloud security teams, these teams mostly focus on building tools and automation for building the defensive posture of the company. Our risk and compliance team works day to day, working with our customers and internal stakeholders to provide assurance to our customers, anyway from designing policies and controls, but also opening up our infrastructure for customers to have real-time assurance into our environment. We have our offensive team, red team, and their charter is to help protect the company and our products, mostly focused on vulnerability discovery and testing capabilities of the rest of the team. And then finally, a CorpSec team that works with our corporate IT and other infrastructure operations team to focus on building capabilities for as you see, the way I think about security is it just needs to be very, very embedded in the business lines. And most of my team works very closely with our product lines, our business units, our external and internal stakeholders, as well as customers who help us inform into future security direction of our program. Just high-level overview. Wanted to give a sense of what a security team at HashiCorp looks like and what are the activities we do. I want to pivot into what has been working well and why security culture is super important. What we've aimed to do in the company is build few different constructs. Number one being security is not just security team's problem. Security is a shared responsibility. It's everyone's it's in everyone's DNA. It's messaged top down from our CEO down to product lines to business units, and everybody understands their role and responsibility in security of the ecosystem. The other big culture we want to push is security is never an afterthought. You will not ship a car and then figure out how to install brakes and seatbelts. We want to distill a culture of secure by default. That also translates into culture of awareness, which is we want to make sure anybody from someone who's writing code, from anybody from who's accessing customer data or designing the product, they understand their responsibility, but they also have the right information and awareness as part of their role and journey in the build out. The fourth bullet is culture of what I call inevitability. Just prepare everyone and just expect that worst case scenarios will happen. That might include incidents or breaches or product failures or new regulations come in. And it helps to align everybody on common threat models. And what I mean by that is, what are you protecting against? What are the top mission and vulnerabilities that might originate, that might impact you as a person, you as a product owner, you as a responsible party for running, managing, operating some piece of infrastructure. We conduct open constructive design reviews and threat assessments. We are a very document-driven company. We share what we learn. No shame postmortems mentions the inclusive nature of retrospectives. Anytime there is a incident or a breach or a vulnerability in our product, we come together as a team, not just the security team, but also the other stakeholders, in documenting what went wrong, what could go better next time, what are the lessons learned, and then feed into constant maturity of our program. That translates into the transparency and trust aspect. Security opens up and shares their playbooks, and we expect others to come and collaborate with us on them. And finally, a note on empathy, really focusing on documented form, communications, understanding. Not everybody is a security expert, but what can security teams do to help instill the message as well as collaborate on better security practices? If you are interested in learning more on what our written document processes look like, there is a small website I shared here called How HashiCorp Works. We've actually opened up quite a bit templates about our RFC and PRE processes that might help you as you think about some of these templates. So With that, I will move into just a brief snapshot of what we are going to talk about in the context of our products and services. The security program I'm going to talk about, just high level, is focused on few different areas. One of them being what we call our HashiCorp cloud platform. If you're familiar with our products, our cloud platform mostly is, think of it as a chassis of the platform that our product teams are building their managed products on for the broader market. We are a multi-cloud company, so we run and support our products on pretty much every cloud out there. There are two different aspects of our cloud. One is what we call the control plane, and one is what we call the data plane. In that construct, there are actually hundreds of services that we've now developed. This is just a high-level abstraction of what it looks like. For folks who have been using Terraform, we also have a Terraform cloud, and the security I'm going to talk about touches quite a bit of interesting threat models that a product like Terraform applies to. So that's just an overview of what are our clouds and what the security program is meant to cover today. Just transitioning into the operating model. Again, these are just distilled themes for some of the security best practices that I'm seeing in the market, as well as what we are focused on. I'll divide the content in 4 different buckets. I'll start with what secure foundations mean for us and how do we think about those pieces. Then I'll cover a bit about prevention, vulnerability detection, and then finally the recovery aspects of things. Cool. So starting from secure foundations, one of the first things people tend to do as they start building infrastructure is see the trends in the market of programmable infrastructure and writing infrastructure as code. As you think about the complexity of people who are writing and designing infrastructure, they tend to be your infrastructure teams, SRE teams, product teams, how they design and building an infrastructure, and they're writing code in Terraform to start designing what does your day 0, day 1, day 7, day 30 infrastructure look like. In that process, you start seeing collaboration and more teams collaborating in different workspaces and designing different aspects of teams. Sometimes what it looks like is one team might own certain services like networking or logging, and some other team might own more of the product infrastructure like login service, billing service, analytics service, and whatnot. And the way we think about secure by default provisioning of infrastructure is just move security as left as possible. Whatever vulnerabilities, issues, things we see in our cloud, all of that feeds into a secure by default infrastructure as code. And in actual output, what it looks like is a set of canned content and libraries that we develop as a security team, which includes some baseline policies and configurations, locking down things by default. To give some practical examples, these would be things like allow only the services that we expect our teams to use, disable by policy public access of S3 buckets, allowing certain best practices on VPC rules and network traffic, like no security group will have 0.0.0.0 egress from external. And all of those policy as code libraries sit with the actual infrastructure as code and provide what I call guardrails for our teams to operate under. That way we eliminate quite a bit of work later in the stage where we're saying, hey, you spun up cloud, you're running infrastructure, and we are constantly finding these issues. We want you to go remediate. And that gives like a good feedback loop on going and fixing where these infrastructure vulnerabilities might originate from. So quite a bit of work in policy as code as well as infrastructure as code security. Some of them we've also opened up as policy packs as part of our Sentinel framework. They are available on our GitHub as well as on our website. So if they're relevant for your organization, by all means, please use them and give us feedback. Moving into the next phase, which I call identity-based security. As I think about zero trust and what zero trust means in modern cloud, it's mostly how do we think about security in the modern cloud? And the way I like to divide this world is in 4 different buckets. A lot of us are very familiar with the user identity construct and how humans get access to certain things. You may be using Active Directory, Okta, some federation service in your company where you have a user, you have a role, and based on your role, you're getting access to certain things. That's this bucket on the right-hand side, which I call human authentication and authorization. What's changing with cloud is as you start designing new applications, new services, and they're going in complexity, how do you think about the machine authentication side? And machine auth could mean various things. It could be identity of your app, of your service, and also what does your app is expected to do, which other services and applications it will talk to. How do you think about machine-to-machine access and authorization? And on the human side, there's also this construct of how do your humans get access to machines, and how does this whole world come together? So there's quite a bit of work that we do in making sure every single app, every single user, every single API call, every single resource has a strong cryptographic identity. They all are designed with least privilege in mind. We are only provisioning the access they need, and then we are continually building automation to remove the unused access. And the way this works is you actually look at the access patterns of either the user or the machine or the service or the app, and look at their activities and build automation to right-size privileges based on actual access. So that's how I think about identity. I'll move into another fun construct, and this is something that is pretty dear to my heart. And the reason it's dear to my heart is I've worked in many companies where security teams and ops teams are constantly struggling to go figure out where the vulnerabilities are, whether those are in machines, base images, operating system, dependencies. And the way we think about solving this problem was, we said, hey, 9 different teams, don't worry about patching, monitoring, hardening your operating system and dependency pipelines. We said security team will provide a first-class service. What we did was we said, hey, we'll take a bunch of requirements, we'll build a hardened-based OS image that we offer as a service. It's a combination of Packer and Terraform and a few different other open source constructs. We pull in the latest patches upstream from Ubuntu, from Amazon, and other distribution providers. And what we are doing there is we are baking in prevention, detection, and monitoring controls, things like OS query, that just become part of the baseline OS image. And then by offering this as a service, we can do a few different fun things. One of them being very quickly figure out the coverage of security controls across production, as well as provide controls where teams can derive these machine images, as well as bundle their own tools on top. But it helps us, one, take control of the patching and vulnerability management and dependency tracking, as well as everything going into production. We can trace back to the code with a verified signed commit that nothing is running in production that is not originating from a trusted source from us. But also you can appreciate how much complexity we are taking away from our ops teams and saying, you don't have to worry now about patching your OS, patching your dependencies, or rebuilding your OS images. Everybody is using these common machine and OS images, and that's helping streamline a lot of hardening, vulnerability management, but also providing consistency in production. So something pretty excited and proud about what our team was able to accomplish in terms of control coverage in a very short amount of time. Moving into some other principle that we want to push in the company is this concept of immutable infrastructure. What I mean by immutable infrastructure is once you push something in production, we don't want people to be changing things in production. Your services remain immutable. When images are launched, they are ready to go, except just getting secrets from the secrets manager, which is Vault in our case. The user data that feeds into the environment is mostly for environment injection only. And the environment is just continuously getting deployed and torn down. To give you a sense of our scale, we are creating and destroying millions of machines a day. And in that construct, what we don't want people to do is go log in and change environments running in production. Everything, again, gets built by something which we have high assurance on, something which is committed in code, signed by our keys, and we have high assurance on. And everything, every time infrastructure is deployed, it's just using the same constructs everywhere. Huge security benefits going down this approach as well. Cool. I'll move into the prevention and protection side a little bit. I think I covered the identity, but I'll dig into a little bit more detail into some authorization and authentication pieces. As you think about some of these problems in the company, this is the core construct of security from our perspective. Every resource, every application, every API, every user, every service gets a strong cryptographic identity managed by a central identity construct. We leverage defined patterns across the infrastructure for both human and machine auth. Quite a bit of this work is actually self-serve with just appropriate guardrails. To give a practical example, we have thousands of accounts spread across thousands of teams, and security doesn't want to be this gatekeeper of we will approve every single access. So what we've done is we've designed this construct of delegation where we build the tools and automation. And when you request access as an SRE or an ops owner or an application developer, you go into this automation, you request, hey, I need access to this account or I need access to this resource. With automation and tagging and infrastructure as code and labeling, we actually know who the resource owner is and who the operational team is responsible for running that service. And the request is automatically routed to the service owner of that team, and they provide access to you based on your role and the reasoning. The fun part about this is the ongoing access also becomes like time boxed and temporal. So you're not granted grandfather privileged access to anything ever. The request review becomes automated. The access review becomes automated. You can delegate these responsibilities to the teams who actually know what the right permissioning model for their application or service would be. And finally, your access is use it or lose it. If you're not using your access goes away automatically. You need access again. You can request access again. And finally, this model I mentioned about permission right sizing, that's huge in terms of to meet some basic security principles as providing least privileged access. All right. Moving into the network side of the business, again, as you think about complexity in modern cloud, we've moved away from this castle and moat model of your conventional data centers where you could put certain security things on your egress point, like firewalls and WAFs and intrusion detection systems. The problem in cloud is, every one API call could open up permissions for your resource out to the public. So how do you think about the changing nature of cloud and the network security, scalability? And the way we think about this is segmenting our components in different layers. So What I mean by that is your virtual machines, your EC2 instances, your databases, your serverless functions, think about their reachability requirements. And what I mean by that is some of them need access, like application services, for example, they might need um, um, traffic access from the outside. Some of them might only need access internally. Some might need only a high assurance access from somebody within the team, only operating from within your trusted environment. So segment those resources in different network layers and then start thinking about what kind of network access control policies you want. And the way we are doing this, again, is pretty much every network security policy is also in code, either using Terraform or some other construct. And the fun part about this, which is mentioned in my second bullet, as we think about like DNS as code and domain as code, is it also helps us start eliminating certain bad patterns. And the way we thought about this problem was, again, security owns a first-class service of which certificate authorities we want everybody to trust. So not everybody is spinning up their own CAs and PKIs and certificate authorities and whatnot. What kind of domain and service naming patterns we want to enforce. And what I mean by that is service running in, let's say, an EU region or a Americas region or APAC region has a certain naming construct. Your dev stage prod has a naming construct. Your service has a naming construct. So then you can enforce like domain and subdomains and some of the security patterns that you're worried about from DNS standpoint as well. And all of those DNS is managed as code. So you can actually go audit the change management aspect of things, but also build some policies where you're just preventing certain bad practices from happening again. So that's how we think about a lot of the network security. By doing this in code, we can also inject common visibility and observability practices. Like every service that will spin up will have these baseline observability and tracing enabled as an example, and they will feed into the same shared common visibility channels. So anytime a new network service gets spinned up, the security team can very quickly discover what that service is, what is it doing, but also helps us enforce common security policies across like geo-blocking traffic or putting a central WAF or putting access policies on our load balancers, for example. Cool. So moving into asset management, this is a fun one for me. What I mean by asset management is just thinking through what is in your environment. How do you track life cycle from sunrise to sunset with versioning? How do you do tagging, labeling as your cloud infrastructure starts becoming more and more complex, more and more self-serve? Like in our case, we are a multi-cloud company. We're literally managing thousands of accounts across various cloud providers. So we built a standard to help identify a few different things, and all of them are written in code and provisioned at the provisioning time when these clouds are spin up, including what's the intent of this service, who is the owner of this cloud, who's going to be on call, what is the application assignment, what is the cost allocation. And these tags and labels actually are defined at like organizational policy, and then they derive back into the resource and the applications that spin up using those cloud services as well. That helps us with also prioritizing even the security events, and it's like which ones should we prioritize more than the other. If it's a production service, obviously a higher priority than, you know, a demo throwaway account that our field team might be choosing. Also helps us like track historical metadata for our environments, and we can go back in time and query how we think about relationships of these assets. We actually feed most of this metadata into like a graph database that we use for like historical correlation and constructs. The other benefit here is we can very quickly track the third-party integrations and data flow, which is hugely helpful from privacy as well as governance perspective. Another fun area, which may be super relevant with all the security events happening in the industry, SolarWinds, CodeGov, and others, how we think about supply chain building our company, our products, and our services. And I try to divide this in a more consumable fashion, but some of you might feel a lot of synergies here in what you are experiencing in your security programs as well, or operation programs. Starting top down, I think the first thing is, what are the dependencies and open source things building and getting consumed in your products? If you look at the supply chain of any major product, you typically have hundreds and thousands of dependencies that build your products. We do quite a bit of work in vulnerability analysis, risk analysis, change management, threat intel about open source components. The other two aspects here are not the open source components, but what are the vendors and SaaS applications in critical path of product delivery, and how do you think about security of those? The way we think about those is anything that is in critical path of product delivery or service delivery, or is accessing customer data, automatically gets the highest assurance security baseline controls. And we design certain patterns where this is how you will introduce a new third party. So there's a code and there's a repo where you go and feed what type of integration that is, who's the integration owner, what type of data you are collecting in and out, and how do we think about resilience aspect of these things. And the other things I mentioned here, which may be unique to us, but might be relevant for some other people, is like the distribution channels from a customer standpoint, the release channels that you are using to consume our products. As an example, how do we think about security and the last mile software integrity on things like Docker Hub and Brew, and other marketplace images of sort. All right, so moving into detection, I think the first big construct here is, how do we do threat management? And pretty much every security detection and response as code. A few different examples here. We do quite a bit of work in building detection as code that helps us build, scale up our security and monitoring patterns. Some examples here. The reason to go down this path is, rather than building detection on top of various security monitoring tools like your SIM platform, your EDR platforms, your firewalls and IDSs, we basically build, hey, all the logs will feed into this common data lake. This is the layer we will normalize and write detection rules. So a good example would be, you want to detect on admin activities. It's one rule that you write, hey, I want to detect on admin user across all of my accounts. So you don't have to do the same rule 50 different times. The same thing translates into what I call response as code. And the intent here is to automate as much manual work using a playbook as possible, where our teams can focus on the business risk and the actual response. And once you have a common response playbook, like, hey, here's a phishing incident, this is how we run playbook. Here's a bucket policy violation, this is how we run the playbook. Hey, there is a new user introduced that doesn't follow our pattern, this is the playbook. So once you just solve that playbook and response as code, you're just eliminating certain classes of issues altogether from your environment. Cool. I'll move into the recovery piece a little bit. This again is we running mission critical services for our customers. And the way I think about resilience is, just understand events might happen, issues might happen, incidents might happen. That's the nature of security business. We expect bad things to happen, but how do you build resilience to recover from those issues? Not just the security ones, but also operational ones. I'll mention a few different constructs which actually have quite a bit of like security benefits as well. The first one being thinking about what are your service quotas and constraints across accounts and regions, and how do you define this in a meaningful way where your teams can operate, but also not abuse, but also if your accounts gets compromised, an attacker can't go and abuse those systems. So we've thought about quite a bit of like granular service quotas and
and aspects there. That translates into how do you actually monitor for leaky and abusive patterns, whether those are from generation and alarm and analytics. We plan for failures, just all sorts of failures on all sorts and all areas of delivery and operation pipelines. We run game day exercises. What I mean by that is not just a hypothetical tabletop exercise, but actually design your service in a way where you just assume things will fail. So destroy your control plane, destroy your pipeline that is feeding delivery of your pipeline, take down your DNS system, take down your ALB, and look at how resilient your service might be, not just from security, but also reliability perspective. The other things to track, again, is thinking about how do you separate out your data from compute when you're running hundreds and thousands of accounts. How do you do backups, recovery tests, integrity tests, and scale this across teams in a meaningful way? How do you design fault isolation and availability zones? And the final 4 bullets I mentioned here is just how we thought about different layers of maturity and helping our teams think through this resilience. So level 1 was just test your backups and restore capabilities. So even if you've enabled backups, for example, have you actually ever tested the recovery process of that backup? That's like level 1 for us. Level 2 for us is like some sort of like a light replication where you're running these sort of pilots where you have replications and backups always on across regions, and you can invoke those services if there is an actual disaster recovery event. And as you become more mature, think about like warm standby, but also real-time active where your workloads may not just be sitting in a different environment, but also actively serving traffic from multiple regions and synchronizing data. So that's how I thought about just mentioning some high-level resilience and availability constructs. Hopefully this is helpful and relevant for some of you. So that's all I had. We are hiring if you're interested in joining a tier 1 security team, building modern cloud security. We are hiring across the board. Please come look at our careers and job openings, and I'll be happy to chat. With that, I'm done. I will stop sharing and look into Q&A. And Frank, how do you want to do this?
Yeah, hey, Tala, there's a lot of questions that came in, so I'll go ahead and just, hey, we can verbally talk through the different questions together here. You've got plenty of time for Q&A, but I just want to say first, great presentation. Loved it, very comprehensive, a lot of good tips here. And, it's great to see an example of building a cloud-first security program with various cloud-first controls, which of course makes sense. I mean, hey, this is HashiCorp after all. And, wanted to dive into some of these questions from our attendees here. And, Ashley says, hey, this is all really good stuff, but a lot of organizations, and maybe some of the ones that you were at earlier in your career, hey, they're not necessarily security companies or cloud-first companies. You mentioned a lot of good things, but what are some quick wins? What should organizations do first to start to move in this direction?
Right. I think what I'd like to start with is just understand your threat model. A lot of people talk about threat models, but very, very few companies actually do this well. And what I mean by that is just help document what are the mission critical things for your company. What are your worst case scenarios that will go wrong? How do you outline what are the things that you want to protect? And your security program will go and protect those assets and address those threat models. And that will inform your hiring plans, your team build out. From technology perspective, I think going back to there's some 4 different constructs in cloud that the way I see it. Like the first one being like the provisioning. How do you design and provision infrastructure? The second layer starts being like, how do you secure infrastructure? So as you design your threat models, like focus on what kind of, pick a framework. I mean, all frameworks are fine. I love using, the cybersecurity framework from NIST. It mentions very easy to explain high-level constructs like identify, prevent, detect, respond, recover. You can help explain this to your non-security teams of like, what does this security program and my controls are meant to cover.
Great. Hey, you mentioned the software supply chain, and you even mentioned kind of SolarWinds and various breaches over the years. And there was a question here in terms of, hey, what can you do specifically? In terms of, hey, you mentioned software composition analysis, your third-party vendor risk management program, and so on. But in HashiCorp in particular, what do you do in terms of kind of signing your base images, making sure that they're not compromised before they're actually signed? What about signing Terraform modules, things like that? Can you elaborate on that a little bit more?
Yeah, absolutely. So we do a lot of signing. We have a huge complex PKI, and I think that there are a few different constructs here. One is as we consume open source, so how do you track what you're consuming? So verify signatures of the upstream components that you're using, but they might be binaries, they might be container images, they might be your dependencies and packages. So signature verification at source. Then what we do is try not to just blindly trust anything upstream. We are actually using and storing them in our internal artifactory, and then choosing that construct, feeding into the build and supply pipeline. And each stage of the pipeline is actually not just verifying integrity, but also making sure these applications and services and users are authorized to perform these actions. So there's layers of defense built in between. Just on Terraform is complex, but to give a perspective, like one, there's this core Terraform binary that we sign. So you can go download our Terraform binary and it's signed using our keys. And when we sign, we're actually looking at assurance of the entire build pipeline of like the actual binary that is produced is only signed after all of those security gates are passed, and we are comfortable that this is something we are comfortable launching to the company. And so that's the core Terraform module. And then there are external third-party providers and modules which are signed using different keys. In like analogy, I like to use like a Linux kind of analogy where your main distribution may come from Red Hat or Canonical or Amazon, but you have lots of other packages which are signed by different types of keys. So when you're doing apt-get install or brief install, you're basically verifying those keys from different keys. So a lot of that is documented on our websites, and you can follow the PKI and the signature verification keys aspects there.
Great. Hey, a lot more questions here. So, for the ones that we don't get to, we'll also post those in Taha's Slack channel here as well that we can get to afterwards. But Taha, you mentioned, hey, you guys create and destroy millions of machines per day, right? And you mentioned, the importance of base images. And somebody asked, for those base images, how do you think about it? Do you follow a specific hardening standard? How do you pick and choose what needs to be in those base images?
Yeah, great question. So the way this works is, we first went to all the teams and said, what do you want to use and what are you using? And guess what? Most people, even sometime when they're opinionated, when you bring them down to like, hey, these are common things. So we can standardize on, let's say, Ubuntu or Amazon AMI or whatever your workload might be. So there are basically 2 or 3 main OS baseline operating systems that our teams are using, and we're trying to like standardize them. So first pick, like align everybody on this is the common distribution we'll work with. Then from hardening standpoint, one is take the base image, remove a lot of like stuff that is never supposed to be used in production. That includes how do you define users and lock down permissions? How do you do file system permissions where you are just disallowing certain things from being enabled in production? Bundling in some security tools like OS Query is a good example, Cilium, other network security things, and just lock all of that down. So when the machine is built and it's booted, we have assurance of trust of like it's booted with the right image, with the right keys, and is also spinning up the security monitoring tools that we have. then what we do also do is it's basically a tree, and then we feed this to other product lines and say, hey, you can manage your own dependencies. We'll manage a dependency tree for you and patch them and manage that pipeline, but you're more than welcome to like put in other packages that you might want, which might be unique for your team. So the teams use and consume the OSMH, but they can't go and change the actual underlying security and the hardening thing. So we picked CIS as the baseline, not the entire CIS, obviously just adjusted based on your environment, but removing all of that abstraction away from the ops team completely.
Perfect. Hey, everybody, Tala at the beginning of his response to this question mentioned a very important thing that I just want to highlight. Earlier in the presentation, Tala, you had mentioned security culture, but you also just started off by saying, hey, we asked the teams what they want to do, and then we aligned it, right? So that's very important, right? And very subtle, but a very important thing in terms of getting people's buy-in, stakeholder engagement. It's not just security telling people what they have to do. It's even more important in a cloud world. And related to that concept, earlier you talked about automating access requests and sending them to the appropriate resource owners. Another good example of making security part of everybody's, the fabric of the culture in the organization. Can you talk a little bit more on how you do that? What technologies do you use to facilitate that process?
Oh boy, that's a tough one. So I might need my slide with 4 different buckets, but the easier ones to start with is the human identity is Okta for us. So we are a cloud first company. We use Okta, where the initial, when you come to the company, we create a user account for you. That's Okta. On the machine auth, that's Vault. So Vault is the identity broker for generating and provisioning identities for our application and services. And then there is stuff in between, and it's various things. Console provides service to service, machine to machine access and authorization using some modern PKI. Console is also open source. If you want to experiment, please, by all means, go ahead. Then we have another product called Boundary, which is also open source, and that's covering what we call the human to machine access. And we have some custom built automation on top, which is all homegrown. Hopefully we'll open source that someday, but that's basically looking at the access and activity patterns of like your, let's say we gave you this role, you are using this role to access cloud. Guess what? You're only using, based on your activity, 3 out of the 15 things. So let's just remove the other 12 things from your permission set. That's custom and homegrown today, but we're actively building it. Hopefully we'll open source that one day.
Awesome. Hey, as I mentioned, there are still a ton of questions that came in. We'll also, make sure to put those into the Slack channel. So Tala, I think people are eagerly awaiting your arrival in the virtual hallway here. So, definitely, hopefully we'll see everybody over there. We are at time here. So Tala, I just want to say, hey, thanks for the great presentation. Great way to kick off the summit overall in terms of this comprehensive view of what you might do from a cloud first security perspective. So everybody, let's give Tala a virtual round of applause. Thank you so much for being here. Appreciate it. And we will see you back here in Slack.